Welcome to this very scary edition of Galileo's Universe. Today, we're going to be taking a look at the science of Halloween and all its spookiness, and you're going to learn not only how to create your own special effects that's related to Halloween, but also the science
behind Halloween. That's what's coming up today on Galileo's Universe. So, Halloween. What makes Halloween scary? It's at night. Halloween's usually not celebrated during the day. And in fact, the importance of lighting and subdued lighting is very, very critical. The angle of lighting also makes a big difference. So that's what we're going to take a look at first, is the effect of lighting. Now, of course, one of the big things that happens in haunted houses is they either reduce the light or take away all the light. Let's find out what happens, sort of the effect on that. Clap off. The effect of darkness leads the imagination to see things that are not actually there. So this effect is achieved oftentimes in movies, and of course when you go to haunted houses, they turn off all the lights, and the lights being off just brings the imagination out, and you start to think that there are things that are there, and also the combined effect of sound effects in the background can also lead the imagination on. So that's why by turning off all the lights in these haunted houses creates a lot of excitement, brings in a lot of fear. It's our own imagination that really generates all the excitement of Halloween. However, you turn out the lights too long and really it takes away the fun. So one of the things that they'll do is add different kinds of lights. So clap on. So let's take a look at one kind of light, and this is often used in haunted houses, and that is a black light. Now there's a couple different black lights. This is a fluorescent black light. There's also ones that are the incandescent black lights. Those, it turns out, don't work as well as these fluorescent kind. All right, so black light, it appears black, sorta. It's actually purple, so why don't they call it a purple light? I don't know. But this is giving off ultraviolet radiation. Now, of course, the word radiation can be scary to people, but it turns out that light is a form of radiation, radio is a form of radiation, X-rays, microwaves, gamma rays, they're all part of this electromagnetic spectrum. So ultraviolet light, what's coming from the black light, or in this case the purple light, is a form of the radiation. Our eyes can't see real well into that spectrum. We can see from red up to blue, but when we go beyond blue into ultraviolet, then we get into different wavelengths. So when I use this, and I use different kinds of paints, for example, and I painted on all different kinds of things, you see that these paints are fluorescing. All right, so how does this work? Well, let's take a look with a little I'm going to turn on a little bit of light here, couple balls here. Now this blue one is going to represent ultraviolet light. And when this blue light, ultraviolet light, comes in from the light bulb and it strikes atoms, it causes the atoms to gain energy. Of course, there's atoms that make up this pink paint and this green paint and even this sort of yellow-green paint. So there's atoms and there's molecules. So this light comes in and it gets absorbed by it. However, we learned in a previous show that it just doesn't hold on to this without doing something. Well, it turns out it can't hold on to this energy for very long. Just like if you eat a candy bar and you gain energy and you jump up on a chair and then your mother yells, "You gotta get back down off the chair." You jump back down, and when you jump back down, you release energy. Well, it turns out that this blue, the ultraviolet, gets absorbed, and then it can re-radiate different colors. It then kicks off another color. Well, in this case, the new color that it's kicking off turns out to be green, or in this case, pink. Only certain chemicals do this. There are some animals that are also able to do this. And in fact, parts of our own body do this. Teeth can do this, where it takes the ultraviolet light, it absorbs it, and then kicks out a blue light, similar to this paint. And other compounds, of course, you can get some kinds of cleaning agents. Detergents oftentimes that you use for laundry will have this chemical. And when it dissolves in your clothes, it then causes your clothes to look brighter under the sun. Why? Well, because the sun is also giving off ultraviolet light. Now, I've got a container here of tonic water, and the tonic water has a chemical that's been dissolved in it that's called quinine. Not all tonics have this quinine. This one does. And you see here the effect of this. It causes it to glow blue under the ultraviolet light. It's not just reflecting it. Water, regular water that has no quinine will not do this. You notice that there's a big difference in here. I've got a little bit of water in the bottom. But this light will re-radiate with the quinine. So the ultraviolet light that they use in haunted houses creates this spooky effect. It also helps in the following way. It's enough light that people can get through haunted houses. So if you set this up in your own haunted house that you created, it will allow people to see enough that they can sort of navigate through a room, that they won't trip over something, but it will also create this eeriness, and with a very little bit of lighting in the haunted house. So while darkness may do it as well, the ultraviolet light will do it just as well. Welcome back. So one thing that I want to show you about fluorescence that we just saw in the last segment was this card is also fluorescent. I hold it up here, it glows green. So it's taking the ultraviolet light, it's then kicking back a green photon. Interestingly enough, I've got a blue light here, and if we move it across, you see very dramatically the effect of this on the card. Now, some of you may have heard of this guy called Einstein. Einstein was known for the special theory of relativity, general theory of relativity. Those were actually crazy controversial ideas when he proposed it. He won the Nobel Prize for physics, but it wasn't for relativity. It wasn't for E equals mc squared. It was actually for something a little more mundane, and it is the photoelectric effect. And this is an outcome of the photoelectric effect. The photoelectric effect just talks about how some of these atoms and molecules can absorb light and kick out new light. It's also the same thing that controls when you go through sensors at a store and the door opens. Sometimes they're controlled by the photoelectric effect. Sometimes you also hear a beep when you enter a store. There's a beam that shoots across there that activates another sensor. Those are all part of the photoelectric effect. That's what he won the Nobel Prize for, not anything that's more common and has been associated with Einstein. So, photoelectric effect also explains what we saw here with the fluorescence. All right, well, so what else is spooky about haunted houses? Well, it turns out one thing that you often see, and not just at haunted houses, is these glow sticks. Now, the glow sticks have got a chemical inside of them. These chemicals are not good, so you don't want to ever break these open. They can be very dangerous. But the way that they make this and the way that it works is a little different than the candle flame. Now, a candle flame is burning. It is combustion. It's giving off heat and light. So what we're doing is we're taking, in this case, paraffin, and we're combusting it. We're burning it with oxygen that's in the air and with a heat source, which we've got to use a match to get this reaction started. And it is chemically changing, and in the chemical change, it is giving off heat and light. Of course, it can also burn incompletely and gives off some carbon. But here, this is different. I'm going to break this, and there is inside a vial, and there's then around it a second chemical. So there's two chemicals that are stored in here. And when the two chemicals mix, it's also a chemical reaction. And the chemical reaction causes it to glow this bright green. Now, this will take a while for it to die off, but there's a chemical reaction that's proceeding. Now, one interesting experiment that you could do with this is you could leave one out at room temperature and put another one in a refrigerator, and you'd find that the one in the refrigerator is going to last a lot longer. The chemical reaction that's occurring here can change, and its length can change depending on the temperature. So this is a chemical reaction that gives off light. Sometimes chemical reactions give off light. They also give off heat. Sometimes they give off only heat. Sometimes they absorb heat. In this case, it's a fairly unique one. It doesn't happen a lot, but this is one of these reactions that gives off light. So this is chemistry. Now it turns out that now what's inside of here, if you shake it, are pieces of that glass container that held one of the chemicals. So this is a chemiluminescence reaction. Luminescence meaning that it's giving off light, and the chemi meaning that there's some chemistry going on. There's a chemical reaction. So that's a fun thing you can do. You can have a bunch of these around in your haunted house. All right, so what's some other things that you can do? Well, we're going to do the next part in the light, so clap on. All right, so far we've been taking a look at just what we observe and what we don't observe, like when the lights are off. But what about other senses, such as our sense of touch? Well, it turns out when I was a kid, set up this haunted house, and then we had everybody crawling through boxes. And then in sort of these holes in the boxes in this haunted house that was in the garage, people could stick their hands into things. Of course, we were telling them that it might be like brains or, guts or something. So there's very common food ingredients that you can use that will simulate this effect. And of course, the key part of this is allowing the imagination to work. Now, there's a bit of the science of psychology that's at work here, because you can sort of trick the mind into believing things that would not actually be. So, for example, you wouldn't go get brains and guts and all that stuff and actually bring it into the garage and do that. But you can use things like, Jell-O, because Jell-O has a consistency that if people don't know what they're touching, can feel like it's guts or, internal organs, very fun stuff like that. So just the texture of this. So Jell-O, of course, it doesn't have to be red, because it would be things that they wouldn't see. So they might be putting their hand into a box, and inside the box would be the Jell-O. Of course, another thing that simulates the effect of sort of guts is spaghetti. So cooked spaghetti also has a very similar feel. Now, of course, when you see it, it's a different story. But if you don't see it and you're being told that these are guts, well, then it sort of freaks people out. Grapes are also very good for simulating eyeballs. So you have an eyeball, but you tell people these are eyeballs, but they're really grapes, but they're not really grapes because this is an eyeball. Then it also has a big effect. And of course, here's another thing. This is actually something that happened in real research. So the ice cream cone looks good, doesn't it? Yeah, no, this is actually, what do you think it is? Mashed potatoes. This is nothing more than mashed potatoes. Now, of course, if this were ice cream, I wouldn't be able to do what I'm doing. Mashed potatoes. It turns out that they did research on this with a real group of students at a college, and they found out that expectation for taste has a big effect on whether they like it or not. So they got a group of people and they asked them, do you like ice cream? Do you like mashed potatoes? Okay, fine. So then they took them to a different place and they put mashed potatoes on an ice cream cone. The expectation was that the people that would be eating this, they thought it would be ice cream. And then when they went and licked it, they had an enormously, it was like a gross reaction. Their expectation for taste that this would be ice cream changed their perception. So that's sort of the bit of a trick that you can play using the sense of taste. So we've got the sense of touch, we've had the sense of sight. You can do some other things that even are done at the theme parks where you can have the sense of smell that's at work as well. So coming up next, we're going to take a little bit more at some of the effects that we see in the fog in the air of Halloween. Welcome back. Now let's take a look at a special effect that's used at one of the theme parks that sort of blows people away as far as how they get these ghosts to appear and dance and disappear. It's actually a very, very simple special effect that you can do at home. All right, so behind me I have a light bulb. This is an ordinary light bulb. Yes, here it is. It's here, and if I touch it, then it hurts. But behind, I have another light bulb because I've got a reflection. However, I'm going to reach behind, and of course you see my hand. Ooh, yeah. But is it actually there? It is not. Wait a minute. How can this be? Well, it turns out that even the cleanest glass has got a reflection. The clearest glass has got a reflection. And it is this reflection that we're using to create the illusion of a light bulb behind here. It turns out that there is no light bulb. There is a light bulb base, but there's no light bulb in the base. So by lining these two up in the following way, it gives the illusion that there is the ghost of a light bulb behind here. So how does this work? How does this effect work? Well, the glass reflects light much in the same way as a mirror. In this case, this is a concave mirror. It also reflects light. Now, of course, a mirror is designed to reflect all the light and to have the light that goes in come right back out. Of course, everything reflects light. Walls reflect light. Mirrors do a very good job of making sure that all the light rays that go in come out in the same direction. And this happens with this plexiglass as well. So by having something that's well lit in front of glass, it appears as if it's inside the glass. You see this effect at night when you look into the reflection in a window. If it's dark outside, or at least darker outside, we see this effect. Same kind of thing here. So by having ghosts dancing around, they shine the light onto the ghost. The light reflects from the ghost off of huge pieces of glass that are in front of you back to you. So very, very simple thing to do. All using reflection, and we're just using a sheet here of plexiglass showing that behind it, there's nothing really there. So another special effect that's used is fog. Now, fog comes in a couple different formats, and one is the fog machine. Now, it turns out that there's a liquid in here that's vaporizing with a lot of heat. I mean, we're talking a lot of heat. These sometimes can be 900, 1,000 degrees to get this to vaporize, and it creates this very eerie mist. So it's a wonderful thing. Okay, well, maybe you don't want to buy a fog machine. You can use one other thing that's commonly available that you can get at stores. Now, the thing is, you will have to ask your parents to go buy this, because this can also be a little dangerous to handle, which is why I'm going to wear a glove to handle this. All right, I've got a container of water here, and I'm going to put in this chunk. And you see that it looks like it's doing something. It's giving off, looks like steam. Could be very hot. Well, I'm going to put it into water. Now, what we see is it's starting to boil. It looks like it's boiling. This is dry ice, and dry ice is frozen carbon dioxide. So it's got one carbon atom with a couple double bonds connected to two oxygen atoms. And if I get it enough, then I cause it to freeze into chunks. Now, interesting thing about carbon dioxide, about dry ice, is that in this solid form, when I take it and I warm it up, it turns immediately into a gas. It actually doesn't go from the solid state to the liquid state up to the gaseous state. It jumps from the solid state into the gaseous state, and this is an effect called sublimation. So it sublimates, turning from solid to gas immediately. Now, of course, when I put it into water, water conducts heat very quickly, and the heat from the water is traveling into the carbon dioxide, causing it to start to sublimate, to turn into a gas. And in the process, it's creating this effect. It is boiling. Well, looks like it's boiling. It's really not boiling. boiling is a different effect. It is turning into a gas through sublimation. Now, you see here that there's what looks like a fog. So the fog that we see here is really truly a fog. It is water that has condensed out to form this mist. So just like fog that you would see in the morning when it's cooler, where water vapor has condensed out and it forms a fog or a cloud that's on the ground, same kind of thing here. The reason we know that is because when this travels over the top of the container, it rolls down, indicating that it's heavier than air. Now, of course, carbon dioxide is also heavier than air, as we saw in our previous show, because it can be used to put out fires. So now, how do we know that this is actually turning from a solid to a gas? So I'm going to do a little experiment here. I'm going to get a little tiny chunk of the carbon dioxide, and I'm going to cap it off in a film canister. And I'm going to let it sit here. Now, what's happening slowly is it's turning from a solid into a gas, and it very quickly builds up pressure so that it pops the top off. So, little experiment that you could do, but you only want to put it in a container like this where it can pop off very easily. If you were to do that same experiment in something like a sealed container, like a 2-liter bottle, it could be very dangerous. So don't try that. Do it only in maybe a film canister that you have where the top will come off real easily. The pressure that can build up inside can be quite large. All right, so this is a huge special effect that's used. You can use this in, you can put it in punches, and it can bubble. Nice thing is it also cools it off. One thing that it does do, though, is it causes it to turn acidic. Carbon dioxide, when it's dissolved in water, can make it taste more acidic. Carbon dioxide is also dissolved in sodas, which also gives it a slight acidic taste. So be aware of that if you put it in a fruit punch, in the end, after you let it boil long enough, it's going to have a slight acidic flavor. This is a little different than the fog machine, because the fog machine is using a chemical that is vaporizing under very high temperature, where the dry ice here is doing something different. And even when I hold it here, and you notice that I'm wearing gloves, it also looks like it's steaming, but really what's happening is it is causing the water vapor that's in the air around it to condense out, forming a fog. So I've got one more thing to show you. Something you see here. So they've got some cloth here, white cloth in this case, with orange lights inside, and the fan that's underneath here creates this special effect that you see that simulates fire. Of course, by putting this inside of a box or hiding it away, it hides the light, it hides the fan, and it's something that will simulate the fire, and it creates a really great special effects. So we're using the light, we're using reflection and the color of the bulbs to really create an awesome effect, and this is used in a lot of the theme parks. So, coming up in a second, we're going to take a look at blood. So blood, you can get these blood tubes, or you can make it yourself using some cornstarch that's been dissolved in water, and I'm going to put in a bunch of red food coloring and dissolve, and with enough food coloring, it will start to look, although I'm going to need a little bit more than this, it'll start to look like the very red blood that you can get at the store. So, with just a little bit of knowledge about science, you can also become an expert at special effects. And just like scientists use their creativity, your creativity can be used to imagine even more than I was able to show here. Well, that's all I have to say about that. Join us next time on Galileo's Universe.